Hello everyone. In this video, we are going to talk about limitations of the octet rule from the unit for chemical bonding and molecular structure, class 11 chemistry. See, the octet rule states that the atoms tend to form bonds in such a way that they each achieve a full outer shell of 8 electrons resembling the electron configuration of a noble gas. Though the octet rule is useful for understanding the structures of most of the organic compounds, it applies mainly to the second period elements of the periodic table. There are three types of exceptions or limitations to the octet rule. The first one is the incomplete octet of the central atom. See, this occurs when an atom has less than 4 electrons in its valence shell but is still stable in a compound. That is, for example, let us consider lithium chloride. See, lithium chloride is an example that illustrates an incomplete octet for lithium. See, lithium has atomic number 3, so electronic configuration 2, 1, it has 1 valence electron. Chlorine, its atomic number 17, so electronic configuration 287, so its number of valence electrons is equal to 7. Okay, so you see, lithium has only 1 valence electron. Chlorine actually requires 1 more electron to complete the octet. When it gets 1 electron, the outermost shell becomes 8 electrons now, so it completes octet. So when lithium bonds with chlorine, lithium donates 1 electron to chlorine and lithium becomes lithium plus ion. Okay, and chlorine gets this electron from lithium, and when it accepts 1 electron from lithium, this chlorine becomes chlorine Cl minus ion. This electron transfer results in an ionic bond. Okay, where this Li plus and Cl minus are attracted to each other due to opposite charges. So here, chlorine achieves a full octet with 8 electrons in its valence shell by gaining 1 electron. And lithium, it loses 1 electron, so its outer electronic configuration, it will be outermost shell, it has only 2 electrons now. Okay, so lithium does not achieve an octet, it has only 2 electrons now in its outermost shell. Okay, chlorine gets 1 electron, so outermost shell, it has 8 electrons now. Lithium loses this electron, so now its outermost shell has only 2 electrons. So lithium does not achieve an octet. Since lithium achieves stability with only 2 electrons in its outermost shell, it does not need to follow the octet rule strictly. So lithium is stable with this 2 electron in its outer shell. It does not need to follow the octet rule strictly. The other examples of compounds with incomplete octet are BeH2, BCl3, AlCl3, BF3, etc. Now, the second limitation is odd electron molecules. See, the octet rule states that atoms prefer to have 8 electrons in their valence shell to achieve stability. However, one limitation of the octet rule arises with molecules that it contains an odd number of electrons. That is, in these cases, it is impossible for atoms to achieve an octet, and that leads to the formation of an odd electron molecule or a free radical. See, nitric oxide, NO, nitric oxide, it is an example for an odd electron molecule. Nitrogen, its atomic number 7, so electronic configuration 2,5. Oxygen, atomic number 8, so electronic configuration 2,6. Nitrogen has 5 valence electrons, oxygen has 6. So total number of valence electrons 5 plus 6, which is equal to 11, which is an odd number. Okay, see, the Lewis dot structure for nitric oxide is like this. Okay, you see there is a double bond between this nitrogen and oxygen atom. So when you consider this oxygen atom, 2 plus 2, a single bond uses 2 electrons. So double bond 4 electrons, 4 plus 2, 6, 6 plus 2, 8. Okay, so you see oxygen is usually assigned a full octet or 8 electrons in its valence shell because it is more electronegative. Now you see here for nitrogen, there is a double bond, so 4 electrons, 4 plus 2, 6, 6 plus 1, 7. Nitrogen has only 7 electrons in its valence shell, so it does not achieve a complete octet. Okay, see there is one electron which is unpaired, that is alone. Nitric oxide NO has an unpaired electron which makes it radical. See, a radical or a free radical, it is a molecule or an atom or an ion that contains an unpaired electron in its outermost shell. The other examples of odd electron molecules includes nitrogen dioxide NO2 and chlorine dioxide ClO2 radical. These molecules cannot satisfy the octet rule for all atoms due to the presence of an odd number of electrons. Now the third limitation is the expanded octet. See, expanded octet is another limitation of the octet rule. It occurs when an atom has more than 8 electrons in its valence shell. This happens primarily with elements in the third period and beyond the third period in the periodic table, as they have access to the d orbitals that can accommodate extra electrons. See, in atoms with an expanded octet, the central atom can hold more than 8 electrons due to the available d orbitals, which allow additional bonding. This phenomenon is common in atoms like phosphorus, sulfur, chlorine, xenon, etc. Interestingly, sulfur forms many compounds in which the octet rule is obeyed as well. Now let us consider one example for the molecule which has expanded octet, that is SF6, sulfur hexafluoride SF6. See, in sulfur hexafluoride, sulfur is the central atom bonded to 6 fluorine atoms. See, the 6 single bonds, there are 6 single bonds around the sulfur atom. So, a single bond uses 2 electrons. So, there are 6 single bonds around sulfur atom. So, total 2 into 6, which is equal to 12 electrons are there around the sulfur atom, which is far exceeding the octet rule. As per the octet rule, for stability, it requires only 8 electrons. But for sulfur atom, there are 12 electrons around it, that is in its valence shell. Sulfur can accommodate this expanded octet due to available d orbitals. Some other examples of such compounds with expanded octet are PF5, H2SO4, etc. So, the expanded octet is a limitation of the octet rule observed in elements from the third period onward. This limitation allows these elements to hold more than 8 electrons in their valence shell by utilizing d orbitals, enabling them to form stable compounds that the simple octet rule cannot explain. Now let us see the other drawbacks of octet theory. See, it is clear that the octet rule is based upon the chemical inertness of the noble gases. However, some noble gases like xenon, krypton, etc. also combine with oxygen, fluorine to form a number of compounds like XeF2, KrF2, XeOF2, etc. See, this theory does not accommodate or does not account for the shape of the molecules. Octet theory does not account for the shape of the molecules. It does not explain the relative stability of the molecules, being totally silent about the energy of a molecule. So these are a few limitations of the octet rule. I hope it is clear to you. Thank you.